Hybridization of multiple bonds molecules. Before we're looking at the molecules containing multiple bonds, let's focus on the molecule that has two central atoms. For example, ethane. Ethane has two central atom carbon. So for this one, the hybrid for this molecule, it will have two hybrid orbitals. The first one for this carbon and the second one for this carbon. For this carbon, it has 4 sigma bond. So it will be 4 electron group, all this unpaired electron. For this carbon, it will be sp3. Same goes for this carbon, 4 sigma bond, electron group 4. It needs 4 unpaired electron. It will be sp3 hybridization as well. So this is for molecule that has two central atoms. For molecules containing multiple bonds means the molecule contains pi bond and sigma bond. For example, ethylene and acetylene. So for ethylene, the ethylene has two central atoms, carbon and carbon. So you need to draw two hybrid orbitals for this carbon and for this carbon. This carbon, it has 3 single bond, 1, 2, 3 sigma bond and 1 pi bond. For double bond, one bond is sigma bond, another bond is pi bond. So for this carbon, it has 3 sigma bond and 1 pi bond. And then we'll look at how it gets sp2. Same goes for this carbon. It has 3 sigma bond and 1 pi bond. Next slide will show how you get sp2 hybrid orbitals. Next, acetylene. For this acetylene, it has this carbon is the central atom and this carbon is the central atom as well. So you have to draw two hybrid orbitals for both carbons. This carbon, it has 1 sigma bond, 2 pi bond. For triple bond, it has 1 sigma bond and 2 pi bonds. So means this carbon has 2 sigma bond, 1, 2 and 2 pi bonds. Same goes for this carbon. Bonds in C2H4. This is the Lewis structure of C2H4. For this molecule, it has 2 central atoms. So you have to draw 2 hybrid orbitals for this carbon and this carbon, 2 hybrid orbitals. First, write down the electronic configuration for all atoms in this molecule. Electronic configuration of C1s2 to s2 to p2 for H1s1. Next, draw the orbital diagram of valence electron of the central atom carbon. The valence electron or 2s2 to p2. Promotion of electron. Look at how many bonds does this carbon has. It has 1, 2, 3, 4. 3 sigma bond, 1 pi bond. So this carbon needs 4 unpaired electron because it has 4 bonds. So from ground state, only has 2 unpaired electrons. So you need to move the position of this electron to the empty 2p orbital, making it 4 unpaired electron. And for the type of hybridization, only mix the unpaired electron of sigma bond. This carbon has 3 sigma bond, so only mix 3 unpaired electron because the hybridization only involves sigma bond, not pi bond. So when you have 3 sigma bonds, you need to mix 3 unpaired electron, 1 from 2s, 2 unpaired electron from 2p, making it sp2 orbital because you use the electron in s orbital and 2 electron in 2p orbitals. So this is 2p orbitals, 3 unpaired electron because you only have 3 sigma bond, and the pi bond does not involve in hybridization, so this unpaired electron of pi bond is unhybridized 2p orbital. The energy level diagram for sp2 hybridization. This is a ground state, 2 electrons in 2s, 2 unpaired electron in 2p, and then you move this 1 electron in empty 2p orbital, mix the 2s, 1 electron in 2s and 2 electron in 2p only, because the molecule only has 3 sigma bond, leaving 1 unhybridized p orbital. The unhybridized p energy level is the same energy as 2p orbital, because these 2p are unhybridized yet, and then this is the unhybridized, so the energy level of them are the same. The energy level of sp2 is in between of pure s and pure p. This is how you draw the hybrid orbitals for C2H4. The first carbon, this one, sp2, because this sigma bond only has 3 sigma bond, so draw the sp2 trigonal planar. 3 sigma bonds means 3 electron group. Actually, it is 3 electron group because this double bond is counted as 1 electron group. So 3 electron group, the shape is trigonal planar. Trigonal planar 120 between all this orbital, 120 degree. So you draw trigonal planar for sp2 hybrid orbitals, and same goes for this carbon, trigonal planar, and then make the sigma bond with hydrogen, unpaired electron hydrogen, 1, 2, 1 and 2. And then for this one, for the pi bond, it is unhybridized. The pi bond is unhybridized. This electron is in 2p orbital. When it is in 2p orbital, you have to draw the shape of 2p. P orbital shape. P orbital shape is dumbbell, so you have to draw the dumbbell shape, and please write 2pz and 2pz because it involves the 2pz here. If you notice in this one, the unhybridized 2p orbital is pz. This is px, py. Those two are hybrid. And the pz is unhybridized orbital. It's better for you to write 2pz in the hybridization orbital. 2pz, and another one is also 2pz. And then when you draw the pi orbital, pi unhybridized orbital, the electron must be the opposite spin, and then draw this line, the pi. The above part will connect it with the above region, and the below region will be connected to this below region. Note that this line, this 1 and 2 line, is not the bond. This is just showing that this orbital is coupled with this orbital. It's not showing that this is the bond. No, this is the sigma bond, and the pi bond only 1. This two line is counted as 1 bond. So it has 1 sigma bond and 1 pi bond. This 2 line is counted as 1 pi bond only. It has 2 overlap region for pi orbital. This unhybridized pi orbital, 2 region overlap, but the bond is only 1. Okay, and please write down 2pz, 2pz. Sigma bond CH, sp2 of C overlap with 1s of H. The H is 1s because the unpaired electron is in 1s orbital, so you have to draw the sphere shape. And CC, this overlapping hybrid orbital overlap with hybrid orbital. Unpaired sp2 for carbon on the left overlap with unpaired sp2 of the carbon on the right. And the pi bond in C double bond C, this pi bond for between these 2 carbon overlap unhybridized 2p for carbon on the left, unhybridized 2p for carbon on the right. Both are 2p orbital because both electron unpaired is in the 2pz orbital. their orientation must be the same. If you draw this 2p straight like this one must be straight like this as well. Their orientation must be the same. Next, C2H2. This is the Lewis structure for C2H2. The carbon has triple bond with another carbon and single bond with hydrogen. So you have to draw two hybrid orbitals because you have two central atoms. The hybrid orbital involves the central atom only. Okay, so this carbon has two sigma bond, one sigma bond with the hydrogen, one sigma bond with another carbon, and another two bonds or pi bonds. So this carbon needs 4 unpaired electrons because it has 2 sigma bond and 2 pi bond. So this carbon needs 4 unpaired electrons. After you wrote the electronic configuration for all atoms and then draw the orbital diagram for valence electron of the central atom carbon. Ground state, 2 unpaired electron. Promotion of electron, you need 4 unpaired electron because you have 4 bonds. It doesn't matter sigma or pi, you need 4 unpaired electron because you need to form 4 bonds. So take this electron to the empty 2p orbital, making it 4 unpaired electron in promotion of electron. And the hybridization only involves sigma bond. For this carbon, it has 2 sigma bond. So only hybrid 2 unpaired electron, making the type of hybridization sp because it involves 1 orbital s and 1 orbital p. 2 electron, 1 orbital s, 1 orbital p. So that's why sp orbital only hybrid the sigma bond. And then leaving these 2 unpaired electron of 2p orbital, leaving it as unhybridized 2p orbital. So for this one, you have to draw, it has 2 electron group, 1 single bond counted as 1 electron group, 1 triple bond counted as 1 electron group. So 1 plus 1, 2 electron group. 2 electron group for sp orbital, you have to draw linear. 2 electron group linear. Okay, we look at the energy level first. The energy level of Pr2s, Pr2p, you mix them, sp orbital, leaving 2 unhybridized electron, unhybridized 2p. This energy level of unhybridized must be in line with 2p energy level. sp in between of s and 2p. And this is the central atom linear hybrid, sp hybrid orbitals, linear because it has 2 electron groups, so the shape must be linear, 1, 2, 180 degree to each other. Okay, we focus on this carbon first. This one and this one, these 2 orbital is 180 degree to each other. And then this 2 pi bond, you have to draw. For this one, it says it's 2px and 2pz. So the orientation of 2px must be different from the orientation of 2pz. And then draw the same for another carbon. 2px, you slightly tilt to the right. This 2px must be slightly tilted to the right. And straight for 2pz, straight for 2pz. Their orientation must be the same. And draw a line to couple the orbital. And note that their spin must be opposite. Okay, their spin and spin must be opposite. So this is 1 sigma bond between carbon and carbon. And then this 2px coupled with this 2px, the orbital overlap region is above and below, but it is counted as 1 pi bond. Same goes to 2px. Draw the green line, above overlap and below overlap. 2 overlapping area but counted as 1 pi bond only. So this carbon and this carbon, it has 2 pi bond because for 2px to pz couple. And then in total 3 bonds, 1 sigma, 2 pi, so 3 bonds in total. And then draw the sphere for hydrogen orbital, sphere because the unpaired electron is in 1s. Same goes for this one. So this is the final drawing of C2H2 hybrid orbitals. sigma bond, CH overlap here is sigma bond, and C with C sigma bond, pi bond for 2px and 2pz. The unhybridized px bond with unhybridized px with another carbon. Same goes to 2pz unhybridized bond with 2pz unhybridized with another carbon, making them 2 pi bond. Next, hybridization of carbon dioxide. This is carbon dioxide. For carbon dioxide, the central atom is carbon, so you have to hybridize this carbon atom, and also note that this oxygen is the surrounding atom. The surrounding atom that has central atom and it also has pi bond, you need to hybridize that kind of surrounding atom as well. The surrounding atom that can be hybridized is the surrounding atom that has central atom and has the pi bond. So for this one, this hydrogen, you don't need to hybridize this hydrogen because this hydrogen does not have the pi bond, even though it has central atom, but it doesn't have the pi bond. For this one, you have to hybridize the oxygen as well because this surrounding atom has central atom and it has pi bond. So you have to hybridize this surrounding atom as well. So hybridize the central atom first, the ground state of carbon, and this carbon, it has 4 bonds, 2 sigma bond, 2 pi bond. So you need 4 unpaired electron, the promotion of electron, 4 unpaired electron, and only hybrid the sigma bond. It has 2 sigma bond, so you only hybrid 2 unpaired electron, making the type of hybridization as P, leaving these 2 electrons unhybridized to p orbital. So this electron, unpaired electron that involve pi bond will not be hybridized. So this unhybridized 2p orbital is for 2 pi bond here. So sp orbital, this carbon has 2 electron group. So the hybrid type is sp and the shape is linear because 2 electron group, so you have to draw linear sp hybrid orbital. And then for oxygen, you have to hybridize oxygen as well because your surrounding atom has pi bond. So to hybridize oxygen, count the number of bonds that oxygen has. So this oxygen, it has 2 bonds, 1 sigma bond, 1 pi bond. And then it also has lone pair. So oxygen need 2 lone pairs, 2 unpaired electron. So when you write down the ground state, 2s2, 2p4, and this oxygen in ground state, it has 2 unpaired electron. Promotion of electron also require 2 unpaired electron because it has 2 bond, 1 sigma, 1 pi, so it requires 2 unpaired electron. And again, only hybrid the sigma bond and the lone pair. So these 2 are lone pair of oxygen, 2 electrons, so 2 lone pair. Hybrid the lone pair, 1, 2 lone pair, and then hybrid the sigma, so 1, 2, 3. So the hybridization involve 1 s orbital and 2 p orbital. Only mix this 1, 2, 3. So that's why the type of hybridization is sp2 orbitals, leaving this 1 unpaired electron in 2p unhybridized. Don't hybridize the pi unpaired electron. This unpaired electron unhybridized. This is for pi bond. So the oxygen type of hybridization is sp2. The carbon is sp. Same goes for this oxygen. It's also sp2. Because left and right are the same. Both have double bond. Both have 2 lone pair. So for this oxygen is also 2sp2 hybridization. And draw the carbon linear. As I've said before, this carbon has 2 electron groups, so linear 180 towards each other, sp sp. And the oxygen sp2, if you look at this oxygen, it has 2 electron groups, 1 lone pair, 1 electron group, 2 lone pair, 2 electron group, 1 double bond, 1 electron group. So 2 plus 1, 3 electron group. Type of hybridization sp2, and you have to draw for 3 electron group trigonal planar. So sp2 trigonal planar. Okay, for carbon it has 2 unpaired electron because this carbon has 2 pi bond. Oxygen only has 1 pi bond, so only 1 2p orbital. Same goes to this oxygen, 1 2p orbital. And if your carbon, the unhybridized carbon, is 2py and 2pz, make sure this 2py will be coupled with 2py of another oxygen that you want to make the pi bond. Make sure the orientation are the same, py coupled with the same orientation. And if your unhybridized for another one in carbon is 2pz, make sure this oxygen unhybridized is 2pz as well. So couple the same orientation. 2 overlap region above and below means 1 pi bond only. Same goes to this one. 2 overlap region above and below means 1 pi bond only. So in total 2 pi bond here. 1 2 pi bond, and then 1 sigma bond, 1 sigma bond. So this carbon and oxygen has 1 sigma bond and 1 pi bond. This carbon hybrid with this one, hybrid sp2 oxygen, 1 sigma bond and 1 pi bond, making this CO2 has double bond on the left and double bond on the right.